Alright, so in this lesson I'm going to explain more about pointers. So let's examine we have the following code. So here I've stated that I'm creating a new variable called myChar, and I have stated to use the data type char for this variable. Now the variable myChar can hold any single byte ASCII character I desire. In this case, I've set the value to the character lowercase a. That means that somewhere in memory I have this. So I don't know where in memory that is, but I know that somewhere in memory is going to be this string of ones and zeros, which corresponds to the lowercase a. We do not know what the address is, only that there is an address. Now, an address in memory is just a number, a sequence of ones and zeros, no more special than any other binary sequence. Let's suppose that the variable myChar sits at position 8 in our 16-byte RAM from the previous example. So let's not write out all 16 bytes. Let's just write out this. Oops. Okay, so here are 3 bytes of RAM from our 16-byte example from the previous lessons. So what I've done is at position 8, I placed the character for the lowercase a. So the variable myChar sits at position 8 in RAM in this example. Notice that the variable myChar has a value as well as an address. The value is lowercase a and the address is 8. Anytime you create a variable, it will have a memory address. Notice that the memory address is not the value. So the memory address of an ASCII character is not itself an ASCII character. It is a memory address. The data type of the variable is not the data type of the memory address where it is stored. A memory address does not care what kind of data is stored in it. So let's again look at this example. Suppose that at position 7 in RAM we had a number 5, for example. And at position 9 in RAM we just have some random sequence of ones and zeros. So here you see in these 3 bytes of RAM there are three different bytes, each byte being a totally different data type corresponding to something totally different, but the memory addresses are the same. The memory addresses still work the same way regardless of the data that is stored at that memory address. There is absolutely no direct relation between the memory address and the data that is stored at that memory address. So if I asked you, please show me the binary sequence that is stored at position 9 in memory, you have all of the information you need in order to give me that information. You would locate position 9, and then you would say, oh, okay, the position or the binary sequence located at this memory address is 11010011. Notice that while you can give me the 8 bits of data that are stored at that particular memory address, you could not tell me what that data is, whether it's a character or a number or something else. Like you've learned in previous lessons, you can't tell what a binary sequence is just by looking at it. So the way that a binary sequence is understood is by giving it a data type. Now, once we say that this has a data type of char for character, then we can know that at this particular location in memory, we not only have this specific string of ones and zeros, but we know that this particular string of ones and zeros corresponds to a character. So in other words, you need two things. You need the memory address, which will give you the actual string of ones and zeros, and you need the data type, which will tell you how to interpret those ones and zeros to make sense of them. Alright, so I've shown you how to create variables of different types. You can create integers and characters. What if you wanted to create a variable that is designed to hold a memory address? To do that, you create a variable with a data type called pointer. A variable with the data type pointer can be used to store a memory address. Now, in programming, a pointer is a variable that will hold a memory address. So for example, I could set the variable to hold the memory address of 8 or 9 or 7 or any other memory address that I want, and then using some technique that I'll show you soon, I can obtain what is located at that particular memory address. We'll get into that later. All I want you to understand right now is that you can create a variable with the data type pointer, and when you create a variable with the data type pointer, you can use that variable to store the actual memory address. And we'll get into this more later. If you have any questions, feel free to ask.